finally, we've been working with all these expressions. We're going to work on equations today. So we're going to solve some equations. Everyone's back in here, so I'm going to close the door. Okay, so when you're solving, my first blank there is going to be a radical equation. We're going to do two types. So we're going to do kind of one type today and one type in our next lovely lesson. But the little blank here should be radical equation. And when I say radical, like that could be a square root, that could be a cube root. I don't think I have any fourth roots, but any kind of a root where you see the actual square root symbol, cube root symbol, whatever. The other type is called where it has a rational exponent. I'm just going to flip the page real quick. So rational exponent is going to be like we have a fraction exponent like we were simplifying yesterday. So what we're going to work on today will all be like you'll see a square root or a cube root. Okay, all you have to do when you're solving these, as best you can, you want to get whatever type of radical, like if it's a square root, cube root, whatever, get the radical alone on one side of your equation. And then what you'll do is, to cancel it out, take both sides to the index of the root. And take both sides of the equation to the index of the root. So what I mean by that, like if you're working with a square root, you're going to square both sides. If you're working with a cube root, you're going to take both sides to the third power. That will cancel out the radical and allow you to solve the equation. Okay, so very first thing I'm going to do in example 1, I'm just going to do my best. Isolate. This first question has a square root, so I'm going to isolate the square root. So it's multiplied by 2, and then I have this subtract 10 outside of it. Get rid of any addition or subtraction first. It's like undoing your order of operations. So we're going to get rid of that 10 by adding it to the other side, and I'm just going to have 2 plus 10, which is going to be 12. Now, we cannot distribute anything to a radical like I've got a 2 in front of it, so I want to move that away. All you have to do to get rid of that is divide by 2. And so I'm going to end up with square root of 5x plus 1 is equal to 6. So this is the part I've got my radical isolated. I got a square root equal to 6. You can't add, subtract, multiply, or divide things out from underneath the radical. What you want to do here, this is a square root, is take both sides. The index there would be 2, so I'm going to square both sides or take both sides to the second power. On the left, literally all it does, square root and squared cancel each other out, so you get 5x plus 1. On the right side, you have to square 6. So that might be where you want to grab your calculator. So this is just going to be 36. And then this is really like two-step equation here. I'm going to subtract 1, and then I'm going to get 5x is equal to 35. Divide by 5, and you're done. And x is going to end up being 7 for this first example. In the second question I have here, same thing. This one's got a cube root though, but I want to isolate the radical. So I'm going to add 10, get rid of any addition or subtraction. So I'm going to add that guy over there. And we're going to end up with, let's see, cube root, 2x plus 1. That whole thing's under the cube root. That'll be equal to 5. If you're working with a cube root instead of a square root like the last question, the only difference is we're going to cancel out the radical by taking both sides to the third power. So cube root and cube cancel each other out. This would just be 2x plus 1. On the other side, you'd actually have to do 5 to the third power. And I don't know, it's been a minute maybe since we've done exponents. There's a special button for a squared, but if you're going to do the third power, like I'm going to do 5 to the third, this little button above the division key, if you're working with your graphing calculator, is called a caret. Looks like a triangle without a base, but that'll give you an exponent that's not 2. So you can type in any number you want. That's 125, and then you got like a two-step equation here. I'm going to subtract 1, so I'm going to get 2x is equal to 124, and then we're just going to divide by 2 and be done. So x here is going to end up being 62. And these are different than the questions we've been working on because it's an actual equation. If you want to go back and plug it into the original problem, you can see that it should satisfy the equation that you have. So you can check your answers here. I'm just trying to run through this with you guys real quick. Okay, now the last one I have here, the main thing I put this on here for do not add the 4 and the 6 together. That's something people will do on accident. So the first thing you want to actually do is get rid of that 6 by subtracting it from both sides there. So I'm going to have 4 times my square root of x. 50 minus 6 will give you 44. Now, I don't have the radical isolated, so divide by 4 first. And then you have just square root of x is equal to 11. This is a little bit less complicated than the last couple questions we did, because when I square this here to cancel out the square root, literally I just have the answer. I don't have to do anything else. 11 squared is 121. Is anybody having a question about any of those 3 problems? Okay, now the 2 at the bottom, I'm not going to lie to you, these start getting a little bit more difficult as we go. So I'm trying to do different scenarios that I thought you might run into. So on letter D, my radical is already by itself, so I don't have to do any steps to isolate that radical. But what happens here, if I'm going to cancel that square root out, I'm going to square both sides, and square root and squared just cancel each other out here on the left. So this would just be x squared plus 3. The problem is, on the other side, you don't want to forget this. Do not distribute that exponent to the 2 terms inside the parentheses. So I have x plus 1 squared. So if I don't FOIL that or use a box or think about that, we'll miss the middle term, and that'll mess up our problem. So don't write like x squared plus 1. That's going to completely miss the middle term. So if you're squaring something, adding or subtracting, this one has adding inside of it. Write it twice, and then think about what you would get if you would multiply that. I'm just going to do like a little FOIL on mine. And if you guys want to draw a box, though, you're welcome to do that. So this would be x squared plus 1x plus another 1x, and then 1 times 1 is 1. Don't write 2 like I did last period. Okay, so x squared plus 3. And then I'd have x squared plus 2x plus 1 if I simplified what I got when I did my FOIL, or if you did a box, hopefully we got the same thing. Now, the question here is the little weird part. Do you guys see there's an x squared on both sides of the equation? If you tried to, like, let's say we wanted to move all our x squared terms to one side, what actually happens in this problem is it cancels out on both sides. So this is not a quadratic. This just gives me 3 equals 2x plus 1. And then we're literally just a couple steps here. I'm going to subtract the 1, so I get 2 is equal to 2x, and then we're just going to divide by 2. Bless you. So x is just going to be 1 here. So it's not as bad as it looked, but it's a little weird because I had to actually do like a FOIL or box. Okay, let me try to do this one more question before lunch. So I have 2 radicals in this problem. If that's the case, what you want to do to isolate the radical, move 1 to one side of the equation, 1 to the other, and that's as isolated as we're going to get it because the 1 radical there has 3 attached to it. But I'm literally just going to add that 3 times the square root of x minus 5 to the other side. Just totally add it to the other side. So we have square root 4x minus 10 equals 3 times the square root of x minus 5. That's as isolated as I can get it. If you got 2 radicals in the same problem, put them on opposite sides of the equation. Now, I'm going to square this, and this will not be bad, I promise, but there's like a little bit extra to it. On the left side, the square root and squared are just going to cancel each other out, so I'm going to have the 4x minus 10. I can just distribute the exponent on that other side. I know you have subtraction under the square root, but this 3 times this square root, this is a product. You have to square the 3, though. That's really important. This should be 9, and this should be x minus 5. The square root and squared will cancel each other out. We'll just finish when we come back. Sorry, guys. Like I had that number in front that we squared, the 3 squared, that became 9. If you have more than one term under the radical, notice I put that in parentheses because I would need to distribute the 9 to both of those terms. Now, once you have that, we're just going to little distributive property, and then you can solve these however you want. I've got, let's see, this be 4x minus 10, and then 9x minus 45. I'm going to do 2 steps in one real quick. I'm going to move all the x's to the right side. I like to try to keep my variable positive if I can. And I'm going to move all the numbers to the left side. So I'm going to subtract 4x, and I'm going to add 45. I'm just trying to do it in the same step to save some space. You're going to get negative 10 plus 45 give you 35. 9x minus 4x give you 5x. And then I'm going to divide by 5. And so x is going to be 7 for this question. Is anybody having a question? Okay, now none of the questions on the front have what we're going to see on the back. So when you do square or take both sides to an even power, if you're working with a radical, you do have the potential to introduce an extraneous solution, which if you guys remember, extraneous solution is just an extra answer that doesn't work in the original problem. I'm going to show you the first example back on the back side here will be kind of why this is the case. But basically for extraneous solutions, what you need to know, and this is important, the even root. An even, like a fourth root, or most of the time I think the questions in this unit that you guys are going to see are going to be a square root. An even root cannot be equal to a negative number. Now, just in general, if we had a square root like by itself and it was equal to a negative number, I just wouldn't even do that problem because it's not going to have a solution. So the problem is if we have like an expression, if you look down the page here, like when I isolate the radical, I've got an expression on the other side. So whatever is under the square root cannot be equal to a negative number, and that's what we're going to check. I'll show you how to do that on this. But what happens is we can introduce an extraneous solution when we square both sides because that can cancel out a negative. Now, I'm just going to put no extra for odd roots for like a cube root or a fifth root. I don't think I have anything except cube roots, but there's no extraneous solutions for cube roots or fifth roots because those can be equal to negative numbers. It's just an even root cannot be equal to a negative number. So a square root, I don't think I have any, but a fourth root, I think all the questions we're going to practice are square roots. So just can't be equal to a negative number. So let me illustrate that with this very first example under here. And this says square root of 7x equals negative 14. Okay, like if I just see this, like I'm done right now, I'm going to say no solution. But let me show you underneath why that's the case. So if I were to not notice that, and I would actually solve this, this is where you can introduce an extraneous solution. You already have the radical by itself. If I square both sides there, I would end up with 7x is equal to 196. If I divide that by 7, cool, that's going to end up being 28. But if you actually plug that in the original problem, if I do the square root of 7 times 28, hopefully I'm on the screen, not minus times, you guys will see that that's positive 14, but that equation is actually equal to negative 14. So if you got a square root and you're equal to a negative number, just stop doing the problem right then and there because you don't have a solution. If you have like what I have on the other three problems here, if you have a square root equal to an expression, so like in this question, x, and these guys at the bottom, I've got an x plus 5 and x plus 7. I don't actually know until I solve the problem what that would be. So what you have to do, and I would just, in the original problem where you got the radical by itself, just check kind of what I have highlighted. As long as that's positive, you're good. If you would plug your answer in and it would make that expression, or that first one up there is just an x, if it makes that negative, then you have a square root equal to a negative, which is not going to work. So you don't have to do this, but I'm just going to I'm going to leave the question right there, and I'm just going to rewrite the question so I could go back up and plug it in there. But what you're going to do, we're just going to square both sides. You already got the radical by itself. And I'm not going to lie to you, these questions on the back are harder than the ones on the front. So square root and squared cancel each other out. I get 3x plus 10. The other side would become x squared, and now we have a quadratic because I have an x and an x squared, which we cannot put together. Now, if it's me, I would tell you keep your squared term positive, so I'm going to move the 3x and the 10 to the other side by subtracting both of those. And then this is going to be up to you. Any of the questions I'm asking you to solve, I promise will be factorable, so that's probably the route I would go. If you're not, the factoring is not your favorite, you can use the quadratic formula to solve any quadratic equation. So on this one, if I tried to factor, which if you can figure them out, that's what I would encourage you to do. So it's multiply a times c and add to get the b value for ax squared plus bx plus c. So here it'd just be 1 times negative 10 and add up to get negative 3. Can we think of two numbers that would fit both those requirements? Multiply for negative 10 and for negative 3? Ethan, what do you think? Perfect. Okay. One of them, and it doesn't matter which one you put first or second, but the factored form would be like x minus 5 times x plus 2. So we're going backwards. I'm putting it in factored form because if I have two things multiplied together to give me 0, then either this guy is 0 or this guy is 0. So you just would tell me what you would plug in for x to make that 0. So here it would just be positive 5. Here it would be negative 2. Now, because my original problem, let me pull this back down so we can actually see it, my square root was equal to an expression. It's just an x here, but you have to check. So just come back up here to the original problem. As long as this expression is positive, you're good. So if I put in 5 there, perfect, we're positive. All right? However, the other answer I got, and we didn't do anything wrong, we did all the algebra right, it's just that potential for introducing an extraneous solution. If I put in negative 2 for x, then we've got a square root equal to a negative number. That does not work, so then that negative 2 is going to be an extraneous solution. So 5 would be my only answer there. If I was doing this on like a test or a quiz, I would just write 5. Negative 2 is going to be extraneous. And it would turn out just exactly the same way as if we did this. If you went ahead and fully plugged in negative 2, it would end up being a positive 2 on the left side, but a negative 2 on the right side. That's how that works. I just plug it into the expression. As long as the expression is positive, you're good. So if I'm going to do like letter C here, I'm just going to go ahead, let me rewrite the question again. So I'm going to go back and plug it in to check my answers here. You only have to check if this is equal to an expression. So if you don't have an x up there, you don't have to check these. I have to check because there's an x, so I don't actually know what the square root's equal to until I get my answers. So I'm going to start out same way. Let me just square both sides real quick. Now this is kind of like that one on the front. The square root and squared are going to cancel each other out on the left. On the right, do not distribute. Anytime you have adding or subtracting inside parentheses that gets squared, I have to multiply that by itself. So FOIL, box, whatever you like. This would be 3x plus 13. Okay, I'm just going to kind of cheat a little bit. I'd get plus 5x plus 5x, so it would be plus 10x, and then 5 times 5 is 25. I'm going to set this equal to 0. Again, I would encourage you keep your squared term positive. So I'm going to go ahead and subtract 13 and 3x just to the other side to set this up. I promise if I give this to you, it will be factorable. This guy I get x squared plus 7x plus 12 equal to 0. So for this one, I got to think of two numbers. If I multiply them, I would get 12. Same two numbers. I would add them. It would be 7. Can you think of two numbers you'd multiply, they'd give you 12, but if you added them together, they'd give you 7? Atticus, what do you think? Perfect, 4 and 3. So just one of them be a plus 4, one of them be a plus 3. Doesn't matter which one comes first or second. Now, my two answers are what set those equal to 0. So negative 4 and negative 3. Now, you just have to remember before you write your answer, I had a square root equal to an expression, so we have to check. Okay, so if I come up here, you don't have to check both sides, just check the expression. Doesn't matter what the number is, as long as it's positive, you're good. If I do negative 4 plus 5, that's positive. That's positive 1, so this is good to go. Just because the answer is a negative number does not mean it's not a solution. That actually works there. And in this scenario, bless you, if you plug in negative 3, negative 3 plus 5 still gives me a positive value of 2. So actually both of those answers work. And I have no extraneous, so I have two solutions to this question. And then we're going to do one more real quick, hopefully here. Fast. Very similar. I'm going to copy the problem just so I have that space to kind of go back and plug my answer. And you guys don't have to do that, but that's what I'm doing. I'm going to square both sides to cancel the square root. The radical's already been isolated for you in these last couple questions, so I didn't have to do any moves to worry about that. So just don't forget, if you have a couple terms, like I have x minus 7, do not distribute the exponent. You got to FOIL or box, whichever one you like better. I'm going to kind of cheat just a little bit. So I got 39 minus 7x. I know I'm going to get x times x is x squared. I'm going to kind of try to combine the linear terms as I think about it. I'm going to get negative 7x, and I'm going to get another negative 7x. So if I put those together, they'd have negative 14x. Now on the end, be real careful. Negative 7 times negative 7 would give you positive 49 if you multiply those together. Okay, set this equal to 0. I'm going to subtract 39 and add 7x because I'm going to try and keep my squared term positive. And I promise you'll be able to factor it if you want to factor it. Otherwise, you can use quadratic formula on any of these. Should be x squared minus 7x plus 10. Can anybody think of two? This one's kind of tricky. So I've got to multiply to get positive 10, but add to get negative 7. What do you think?
Negative 5, negative 2.
Yes. If you have to multiply to get a positive number, but add to get a negative, both of the factors have to be negative. So negative 5 times negative 2 give you the positive 10. Negative 5 plus negative 2 give you the negative 7. Okay, now here, 5 is one of my possible answers. We just have to check because this was equal to an expression. Now, if you guys look back up here, my square root is equal to x minus 7. So now we have our two options for x, but my square root cannot be equal to a negative. If you plug in 5 right here, 5 minus 7 is negative 2. No bueno. That makes that negative. Square root cannot be equal to a negative number. If I plug in 2, 2 minus 7 is negative 5. Also, no bueno. That makes me have a square root equal to a negative. So actually on this last question, this is no solution because both of the answers that we got ended up being extraneous. So you only have to check if you have an expression. If you have a radical equal to a number, if it's a positive number, don't need to check anything. If it's a negative number, just stop. You have no solution. And if you have a cube root, you don't have to check because you can have a cube root be equal to a negative. You only have to check if you have a square root. And then I tried to do all the scenarios you could do. So like here, neither one of the answers worked. Here, both of the answers worked. And then here, you had one of each. So it just depends on the question. You got to check your expression. Make sure your square root does not equal a negative number. Is anybody having a question at the moment? Okay, sorry, I'm going to stop.